Ammonia NH3. Let us first see the different methods of preparation of ammonia. Ammonia can be prepared by the decomposition of urea. Initially, urea reacts with water. It gets converted into ammonium carbonate, which then gives ammonia, carbon dioxide and water. Next method of preparation, ammonium chloride reacts with calcium hydroxide to give ammonia, water and calcium chloride. Ammonium sulfate reacts with sodium hydroxide to give ammonia, water and sodium sulfate. Next we shall see the conditions required to get a good yield of ammonia. We know that ammonia is manufactured by Haber process. So which are the conditions required to get a good yield of ammonia? Pressure should be 200 atmosphere, temperature 720 Kelvin and catalyst iron oxide mixed with K2O and Al2O3. Earlier iron was used as the catalyst and molybdenum was the promoter used. In ammonia, nitrogen atom has 3 bond pairs of electrons and 1 lone pair of electrons. There will be stronger lone pair bond pair repulsion along with bond pair repulsion. As a result of this, the bond angle in ammonia is found to be 107 degree. The molecule is therefore pyramidal in shape. Now consider the reaction of ammonia with water. In this reaction, ammonia acts as base and water acts as acid. Since water acts as acid, it will donate a proton to ammonia. So ammonia changes to NH4 plus and water changes to OH minus. Ammonia can precipitate hydroxides. For example, zinc sulfate reacts with ammonium hydroxide to give a white precipitate of zinc hydroxide and ammonium sulfate. In a similar way, if ammonium hydroxide is added to ferric chloride, we get a brown precipitate of Fe2O3xH2O along with ammonium chloride. Another important point is that ammonia acts as a Lewis base. It is due to the fact that in ammonia, nitrogen has a lone pair of electrons. So, ammonia will act as electron pair donor and hence ammonia is regarded as Lewis base. Now, what is the use of ammonia? It can be used in the detection of metal ions. For example, if ammonia solution is added to copper sulfate solution, the intensity of the blue color will increase. Initially, we know that copper sulfate is blue in color. But when we add ammonia solution, it forms a complex ion which is cuprammonium ion and this complex ion is deep blue in color. So it is due to the formation of the cuprammonium ion that the solution turns deep blue. Now another example, we know that chloride ion is detected by using dilute nitric acid and silver nitrate solution. So here in this case we get a white precipitate of silver chloride. When ammonia solution is added to silver chloride, it becomes soluble and it is due to the formation of a complex ion. Here again it is AgNH3 twice Cl. So due to the formation of an amine complex, it becomes colorless. Nitric acid HNO3. Nitric acid is prepared in the laboratory by the reaction of sodium nitrate with sulfuric acid. Along with the HNO3, NaHSO4, that is sodium hydrogen sulfate, is also obtained. Now let us discuss the manufacture of nitric acid by Ostwald's process. Which are the various reactions that takes place in the manufacture of nitric acid. In the first step, ammonia gets catalytically oxidized to nitric oxide in the presence of platinum rhodium catalyst, 500 Kelvin temperature and 9 bar pressure. Along with nitric oxide, water is also obtained. Nitric oxide thus formed further gets oxidized to nitrogen dioxide. Nitrogen dioxide then reacts with water to give nitric acid. Along with nitric acid, nitric oxide is also obtained. This nitric oxide formed can be used in the reaction again and again. So these are the steps involved in the manufacture of nitric acid. We know that nitric acid is acidic in nature. So when it reacts with water, nitric acid will act as a proton donor. It donates a proton to water. So water changes to hydronium ion H3O plus and nitric acid changes to NO3 minus. Concentrated nitric acid acts as a strong oxidizing agent. Now let us see the reaction of metals like copper and zinc with concentrated nitric acid. Copper reacts with concentrated nitric acid to give cupric nitrate, nitrogen dioxide and water. In a similar way, zinc reacts with nitric acid to give zinc nitrate, nitrogen dioxide and water. Reaction of copper and zinc with dilute nitric acid. Just now we have seen how these metals react with concentrated nitric acid. So now let us see how they react with dilute nitric acid. Copper reacts with dilute nitric acid to give cupric nitrate, nitric oxide and water, whereas zinc reacts with nitric acid to give zinc nitrate, nitrous oxide and water. Note that there is a difference in the oxide of nitrogen formed. Copper gives nitric oxide whereas zinc gives nitrous oxide. Next, reaction of concentrated nitric acid with nonmetals. Nitric acid reacts with nonmetals like carbon, iodine, phosphorus and sulfur. Note that in all these reactions, the byproducts obtained are water and nitrogen dioxide. So carbon reacts with nitric acid to give carbon dioxide, iodine reacts with nitric acid to give iodic acid, phosphorus gives phosphoric acid and sulfur gives sulfuric acid. Next we shall learn about brown ring test. You know that brown ring test is performed to confirm the presence of nitrate in a salt. How is the test done? To the salt solution taken in a test tube, an equal volume of ferrous sulfate solution is added and then concentrated sulfuric acid is added along the sides of the test tube. Formation of a brown ring at the junction of two liquids confirms the presence of nitrate in the given salt. So what is that brown ring due to? Let us see the reactions involved. Nitrate reacts with ferrous ions Fe2 plus and H plus to give nitric oxide NO, Fe3 plus and water. FeH2O 6 times 2 plus then reacts with nitric oxide NO to give a complex which is nitroso-ferrous sulfate. So it is due to the formation of this complex ion that the ring gets a brown color. So the brown ring is due to the formation of nitroso-ferrous sulfate, the complex ion FeH2O 5 times NO 2 plus.